Hello all, welcome to Ambari Cloud YouTube channel. And today I'll be presenting ReWrite position deletes as part of our Iceberg maintenance. As always, you should fully aware of this metadata layer. What are what are the metadata files and how we're gonna expire metadata files, and I will upload the new video later. Then what are the manifest lists, which is a snapshot file, and then manifest file, which shows the location of your data files. Then we should know how to rewrite these manifest files. Then data files, as number of data files increasing, I know we should aware how to do the rewrite of the data files. When you do the rewrite of data files, how these manifest files are rewritten. Sometimes we may not be able to do continuous more often data files rewrite, then we should know how to do manifest file rewrite. So these are part of maintenance, right? Those videos I have already uploaded. Then and later I'm going to upload how to expire snapshots, so that way then we reduce the time travel, automatically reduce the storage. Then in the as part of data layer, right? Based on your table design, I will walk to cover more tables, and you will create a delete files or insert files, and then those need to be rewritten to improve the performance. And then we need to also know what is the strategy of data files rewrite versus delete file rewrites, and then what are the delete files I will walk. Okay. So more table. Merge and read are tables to handle row level update deletes efficiently, right? So let's say you have a streaming and you want to do more updates and deletes along with insert, of course. Then you need to design a more table. So then there's other table, copy and write. I will also discuss about cow table. So these are tables where when you do update deletes, it rewrites the entire data file, right? So here it won't touch it won't touch the existing data file. It reads the data file and creates a new delete and insert file. But here it takes the entire data file and rewrite. We'll discuss about. So update deletes are tracked in separate file and more table. When you update the record in more table, the original data file remains untouched. Instead, a new file containing the updated rows is created. Right? And so what you do is a small new file. Updated rows will be created. Just only updated. So what is update? Then we should also have a delete row, right? So they will they will create a position delete. So then delete files are generated to mark rows that are no longer valid, right? So when you do delete, then it reads the original file, identifies the row location, then the position of the row, then creates the delete file with the row position, right? So when we read, right, these new row update new rows and delete rows files, they're all merged together with the original file, original data files, right? So Iceberg merges the data from the original data files with update and delete with storing separate, right? So that merge process is slow, right? So of course it's happening on fly, right? So the Iceberg engine will take care of it. So what are the benefits? Faster writes, right? Updates are generally faster in more tables as compared to cow table, and then it allows the frequent updates, right? Okay. And what are the drawbacks? Slower reads, right? Because every time when you read, the original data file has to merge with your insert row file and delete file, and then then the data frame has to work on it, and then it's like kind of slow. As compared to cow table, right? But if you look at the cow table, it reads only the actual data file as compared with the original data. So I will walk through the cow table design also. Then So since it is introducing delete files and update files and the sequence number, dangling files, all the things, this is complex, right? And then it needs some additional storage, but it's not like as compared to Kotlin. Okay. So let's look at also how the delete works. So you have a data files, you delete, then your data file stays as is. Right? It's not cloning. I'm just throwing an as animation there. But these files are then it creates the delete files. Right? Delete one, delete two, and then whatever the so it reads the file, right? And so this is before and after, right? Identifies the position of the delete, then that just writes the delete position, the row delete, right? Um, okay. So, but since we have too many data files, delete files, what we need to do is, more often, we need to rewrite and combine them into, bigger delete files. Okay. So what happens in update? When you do update, this is before, after update, you will have each file have delete file, insert file, delete file, insert file, delete file, insert file, and then when you do read, so it has to read all these three files and merge it together and display your data with latest. So we remove the old row and then insert the new row and then display to us. So this is how an update works in the mode. But when you do rewrite, of course, then these files are merged together, and then the query performance is better. Okay, this is how more table works. But at the same time, these are delete. So the rewrite of the delete files. But as a maintenance procedure, we do data files rewrite. So when you do data files rewrite, this is before how the files looks like it here. And when you do rewrite, then these delete and insert files will merge with the original files. Then you will have only data files. Then the delete and insert files will be disappear. And of course, this way, then performance almost better because it's giving less files. So your maintenance is always rewrite the data files and then but of course we cannot do rewrite data files more often as compared to rewrite of the deleted insert files. So the frequency is higher when you do in your maintenance. But if you have, of course, we have updates and deletes. Um, do more often rewrite of the delete files. Then your daily operation or maybe each partition wise hourly, then you have to do data files rewrite. So then the files will be compacted. Okay. So just what is the cow table we need to know as compared to file. So tables are the traditional approach for handling data updates. Traditional approach is when you do a lot of batch processing. Okay. So when you do delete and update, then what you do is when you update a row in the cow table, the original file isn't modified, right? Of course, we don't. Files are always immutable because of the time travel, so we never modify any original files. Whether we create the delta files, which is done delete and insert, or we're gonna clone the entire file and make make the changes. So here in the cow model, right, in table design, we're gonna completely new file is created containing the updated version of the rows along with any unchanged rows from the original file. That means, let's say you have a 1 gig file, and that 1 gig file is cloned and then rewritten whatever the rows need to be modified. Right? So that's what it is. So your original file as it is, then you have a new file, clone of the new file with the changes. Of course, read access are faster because you're reading a file, not many file delete file insert files. So then read is faster. The old file is on the tank file. So as I said, the new files are essentially copies of the original with calculate changes and makes the read faster. Benefits: faster reads, right? Simple structure because there is no same sequence number of delete file, same sequence of insert file. then combining, then no dangling and all the stuff. So simple structure. Drawbacks, definitely more storage, more storage. The storage is because let's say you have 1 gigabyte file, then you're gonna clone it. Let's say you change only one row, and then what that 1 gigabyte will become 2 gigabyte, right? So careful on that. This is particularly true when you do small updates, and big files, right? So lot of storage. A small update in one row of a 1 gigabyte file become automatically 2 gigabyte in your storage. So and so but if you need a faster read, yeah, well then you copy it. So again, you have to mm, think carefully when you're designing the power more table based on your use case. Okay. So these are files before. When you do a delete update after, then these files are cloned, and then you will have both files, right? So these are files before update, and those files are then you have brand new files. Then you get this. Then you will have a double storage on it. Okay. Um, Cow tables when read performance is critical and your updates are infrequent or large batch jobs. More tables, write performance is priority, and you can tolerate slightly slower reads. This is ideal for table undergoing frequent updates. So in essence, use cow faster reads and slower rates and potentially higher storage needs. No, actually, more storage needs. The more prioritizes faster rates at the expense of slightly slower reads and the more complex table structure. More complex table structure keep saying is on the actual on the files, the sequence number and all that stuff. Okay. So why you need to rewrite the data files, right? As I said, combining too many small files into big files. That's where then you are reading only a few files. Otherwise, you have to open, read, and close. It's a lot of operations when you do too many small files. Then there's another issue is dangling delete files. What are the dangling delete files? So when you Iceberg relies on sequence number to track data and delete files. So let's say you have a data file 1, 2, 3, 4. Then delete files. When it creates a delete file, it also assigns the same. It uses the similar it's not similar, same sequence number, and then when you merge it, you use the sequence number. Otherwise, I have a delete file. The delete file belongs to who? Right? We should know the original data file certified user sequence number when you assign the data files and delete files. When you rewrite file operations performed, right? Rewrite data files, right? Then the they start the same sequence number, right? So let's say you have a data file 1, 2, 3, 4, and then when you rewrite, right? It uses the same sequence number for a rewritten data files, and then going forward and newly deleted files also, right? So now you have a old delete file, old data file, new data file with the same sequence number. Then of course snapshot is different. Then they have a old delete files, same sequence number, new delete file, same sequence number. So this can lead to a situation old delete file referencing the original data file becoming damaged. Okay, because then there don't need to be any more. They don't need. So we don't need it, right? They aren't needed anymore since the data files are rewritten, but the sequence number prevents them from being automatically cleaned up, right? Then do the data files rewrite. So you have a data file as a sequence number. Delete file uses the same sequence number. When you rewritten and using the same start sequence number, then again some same sequence number is used, and for the rewritten data files, and then any upcoming new delete files, then we have old delete files pointing to original data files, and they are like, they're not used. Yeah, they're useful for time travel, but again, since we rewritten, there need any more since the data files are rewritten. So to prevent, and then if we don't rewrite, and then we do only the data files cleanup, and some of these data files, delete files are not clean up. So, rewriting delete files with a new higher sequence number ensures they are eligible for deletion during the future cleanup process. So when we rewrite, then we are combining all these delete files into one new delete file, and it has a different sequence, right? So basically, it's called dangling, right? And then don't spend too much time on it, but think about there is a sequence number issue comes in if you are not rewritten the delete files. Okay, and then of course compaction, right? When combining many small delete files with if you have a lot of sequence updates on the same row or on the same files, and then you need to compact it, and then so these numerous files can slow down compaction jobs in Iceberg. Of course, we have to. Another problem is not only read problem, then also compaction, right? So then it slows down. So do more often, rewrite the delete files. Then that way, otherwise you have thousands of small delete files, and then compacting them is itself takes time. So keep rewriting delete files. Okay. Um, so potentially group them together to fewer larger files, improving the compaction efficiency, of course, read efficiency too, right? Um, so what is the benefits? Removes the dangling delete files, freeing up storage space, improves the compaction, improves the read and all the stuff. Okay. Now let's do demo. Okay. So I'm going to run. Okay. So I'm going to start my Jupyter. Start. Okay, let's go to my maintenance demo. Maintenance and rewrite position deletes. Okay, let's run it. So here I'm starting the Spark session, right? And I'm going to create a database is not there, right? Then so the kernel is starting. Let's wait for yeah, it's almost coming there. Okay. Yeah, I'm using a single node cluster, so yeah, kernel start really slow. Okay. Yeah, sometimes if I'm running too many processes, and it takes time. Yeah. Mm. Mm. Okay, where is my file? Let's do it. I need to set up that value here. No. Okay. Talk session started, and I'm going to use a database, and then so then I have the database DB2. Then I'm going to use the database, and then I'm going to drop it. The table is there. I'm going to create the table, then show tables, then look at our location. of the files. Okay, so since I empty table, right, and then I'm going to insert data, right, insert more data, insert more. Then I'm inserting a lot of data, and this I want to create. Then check the counts. Yeah. So this data frame is created. So now I have 1,000 rupees. So what I will be doing here is I'm going to delete a row, right? Then I'm going to delete one more row. Then just delete some rows, right? I want to see if you look at here, delete files. So I'm looking this one. Show me the delete files. Then we can query your delete files from your table metadata. So here, if you look at very important, the file path and the delete files, all files, data files, and files, and the delete files. So if you enter data files and then you will see all the data files and delete files. Let's look at the same delete files. You will see the same files here. Okay. Now I'm going to do some updates, right? Then again, rest on the delete files. Now you have more delete files because what is an update? Update is delete and insert, right? So what it does is it's going to create a position delete, and also you will create a new insert row, and then when combined, the delete row is deleted from the original data file, and then new insert row is added, so that we will have latest data. So now let's run, here. Yeah, if you look at here, 1, 2, 3, 5 here, and previously we have 3 because we have 3 deletes and 2 updates. So this is how, yeah. Now I'm going to do one additional deletes, right? And then just look at the delete files here. More, yeah, just 6 files. Right? Okay, so what I will be doing is I'm going to rewrite delete files, right? While you're rewriting, you can rewrite all, then you can specify the target size. Again, since the tiny delete files, just write a, so let's do the rewrite position deletes. Okay, let's run that. Okay, so now we have 6 files, right? Then since they're all in the same partition, they will be rewritten. Then now let's run the delete files, right? Because this is now it's become only 1, right? 6 become 1 here, right? But if you okay, so now let's just okay, 1 file count. Now when you run here in the disk, right? Still all the delete files are there, right? Why? Because we need a time travel, right? And so that's the reason we kept it. So, but when you do data files rewrite, then this delete file also gone. Then when you do time expert snapshot, then this delete file is gone. Okay. So here, the 6 delete files become 1 delete file, but the old delete file is still there because of the time travel. Okay. So then what is our maintenance is more often than your delete file rewrites, position delete file. Then you do daily or depends on your partition strategy and right your requirements, right? You're gonna rewrite the data files. Here I'm rewriting the data files. Then I have a 45 data files. Then come back. Now let's look at the data files. Yeah, now we have 4 data files out of 45. But if you look at on the disk, you will see these 45 files. The reason is time travel. Okay. Now let's see my delete files. I don't have any more delete files, as I said previously, right? And when you do, right, let's go to the call here, right? When we rewrite the data files, these delete files are gone, right? Same thing happened here. So when we do the rewrite of the data files, the delete files are gone. But here, when you do rewrite of the position deletes, the 6 rows, 6 files become one. Right? So this is your strategy of your table maintenance. If you have a lot of updates and deletes, more often run the delete file compaction, then do your data files compaction. So don't do other way around. Right? It's always better do delete file compaction than data file compaction because it's faster. Right? And then your data file compaction may be not that frequent as because of it requires a lot of resources, but then folks are reading those files, the table data, then you need a performance. So do more often position delete compaction even in the daytime. Then in the nightly you can do data file compaction. So this is how you build your daily compaction procedure. So related to data files. So delete position deletes, then data file delete. So just follow that the strategy. So this is about the demo, and anything if you have any questions, please contact me here. This is info. Thanks for watching. Okay, thank you guys. Talk to you later.